Hello everybody and welcome back. So in this video we want to code the Hill cipher. It might be a little challenging because the Hill cipher is a little bit complicated, but we will do our best and hopefully we will succeed. So first of all, what we're going to use is the Numpad library. So we need to import NumPy as an NP, and then we need to use the extended Euclidean algorithm. And one way we can do that is we can from egcd import egcd. And how to get this is just pip install egcd. And then we need to have an alphabet. And then what we want is that we want a dictionary to be able to map a letter in our alphabet to a number or an index, and then we want to be able to swap that index to a letter. So we want a letter to index dictionary. And one way we can do this is like this. So what this does is that the zip function maps the first element in alphabet to the first element of the range len of the alphabet. So in this case it will be A will be mapped to 0, B will be mapped to 1, etc. And then we just make a dictionary out of that. And then we want to have another dictionary that maps a index to a letter. And we do this by essentially doing the same thing, but we do it in reverse. And then what we want to do, I'm actually going to cheat a little bit here. I've done this before, so I'm going to copy paste this code and I'm going to walk through it instead. But this is a little bit of what's complicated in the Hill cipher, is that we want to find a inverse of a matrix in a specific modulus. So let's go through it. The first step is that we want to find the determinant. So what we do is that, well, we use numpy.linear algebra, and then we find the determinant of a specific matrix that we input. And then we want to round that because the Hill cipher matrix that we use is going to be integer, but because of numerical round-off errors, we might get something that's not an integer. So we round it and we make sure that it's integer. And then what we want to do is that we want to find the inverse of the determinant in a specific modulus, right? So we want to be able to know, well, what is this determinant in a specific modulus? And we use the egcd function for that, where we send in the determinant and the modulus. And then we also take that modulus. Might be a poor choice of variable name, but anyway, after we found that, what we want to do is we want to find the matrix modulus inverse. And what we start with is that we take NumPy and invert that matrix. And one thing that I showed in the previous video is that the inverse of a matrix is the determinant times the adjoint of that matrix. So rather, it's the inverse of the determinant times that matrix. So it's 1 over the determinant and then times the adjoint of that matrix. So if we then times the determinant, then what we get back here is just the adjoint. And then we round that, and then we apply modulus element-wise to each of those in the matrix, which will be the adjoint. And then we want to times the determinant in that specific modulus, which we've calculated in step 2. And then we're done with that part, and we have a function that returns the matrix modulus inverse. Alright, and then let's do a quick skeleton code of what it is that we want to do in the Hill cipher. So we want to encrypt a message with a specific secret key K, which is a matrix. And what we want to do in this function is that we want to make message into numbers first. We also want to split it into the size of matrix K. And this is so that we are able to do the matrix multiplication. And we want to iterate through each partial message, which will be created when we split our message, and encrypt it using K times P and modulus 26. And then we want to map it back to text. Yeah, so let's start there, or actually then we want to have a decryption which take a ciphered text, and that takes the inverse of K inverse, and we want to do pretty much the same thing but the opposite. So we want to make ciphered text into numbers. We want to split it into the size of matrix inverse of K, which will be the same because it's a n by n matrix. So we can do matrix multiplication, and then we want to iterate through each partial ciphertext and decrypt using inverse of K times C and then modulus 26. And then we want to map back numbers to decrypted text. And then we want to have a main function that just runs these encrypted and decrypted. Okay, so first of all, what we want is we want to have an empty string where we will store the encrypted text, and then we want to have some way of storing the numbers. So let's say message in numbers. And how we do that is that we can just go through 4-letter in message, and then we can just add it to the list message in numbers. So message in numbers dot append, and then letter to index of that specific letter. Alright, then we want to split it into the size of the matrix K. So we want to split message in numbers to the size of the matrix K. How we can do this is that we can call it split P using the notation that we did in the last video. So we want to message in numbers and want to split it from I to I plus integer of K dot shape 0. You could use 1 here also, since it's in n by n, so that they will be the same. And we want to do this for I in range 0 to the length of our messaging numbers with a step of integer of the shape of K. So if K is 2, then we will start with 0 to 2, and then from 2 to 4, 4 to 6, etc. And then we want to go through 4P in split P. We want to, first of all, we want to make it as an array. And we also need to take this transpose because we want it as a column vector to be able to do K times P. Now it's a row vector. And then one thing to keep in mind is that if we have, for example, a message of length 5, then we will split it 2 and 2, and the last one will become 1. But we need it to be a length of 2 to be able to do the matrix multiplication. So what this means is that if this does not hold, then we don't have the same, we are not able to do the matrix multiplication because the P is of smaller size. And what we need to do then is that we need to add something to the end of p. And when we could add, for example, an x to the end. And we can call this our new p. And actually, one thing we need to do more is, because NumPy is a little bit tricky, we need to add just numpy.newAxis. And if we do this, then the matrix multiplication will work as it does in mathematics, as we expect it to work. So we can just add this to the end. And then what we want to do is we want to do the matrix multiplication of k and p, because now we're able to do this multiplication because of the this two lines of making the length of p the correct size. And then we want to do this modulus, the length of our alphabet. Let's call these numbers. And then what we want to do is that we want to map it back to the text. Yeah, so let's see. We can call n to be the numbers of the shape of 0. So how many elements, essentially, if we have a 2 by 2 matrix, this will be 2, but if we have a 3 by 3 matrix, this will be 3, etc. And then we want to go through for each of them. So for index in range of n, then we can call that specific number the integer of numbers of index comma 0. So remember, this is a column vector, so this will go through each row, and then this is just the first column, and it will just be one column. So this is unnecessary, but just to be specific. And then what we do is that we add this to encrypted. So index to letter of that number. And I guess, yeah, this step here is what we're doing here. And then we return encrypted. Alright, so hopefully we have now encrypted. We can try to run this. And we need to have a matrix k first. So k is an numpy.array of, let's see, 3 by 3 comma 3, 2 by 5, I believe is the example we chose in the last video. So let's stick to that. And let's say we have the message help, as we did in the last video. And then let's say encrypted message will be encrypt of message comma k. Yeah, and let's print. Yeah, and we get HIAT, which we did in the last video as well. So that's great. That means that encrypted is most likely working. And let's go to the decrypt. And we want to do essentially the same thing now as we did in the encrypt, but opposite. So we can first call decrypted to be an empty string, and then we want to cipher in numbers, empty vector, and then we want to make the cipher text into numbers for letter in cipher, and then cipher in numbers dot append, and then letter to index of that specific letter. Awesome. And then we want to split it. So split C is cipher in numbers, and same thing as we did before, just I to I plus the integer of k dot inverse, k inverse of shape of 0. Yeah, like this, and then yeah, like this, and then we go for I in range 0, comma length of ciphering numbers, comma integer of k inverse dot shape of 0. So that's a step, and it will just be the same size, so 2 if we have a 2 by 2 matrix. Then we want to, for C in split C, we want to do the same. We want to take the transpose of as array of C, and then we need to do dot np dot new axis just to make the shapes match up, because NumPy does something funky. So let's see. Then we do NumPy dot of k inverse comma c, and then modulus the length of our alphabet. And remember, the k inverse is a bit complicated to compute, but we did it in the first function up here, and we're gonna run it in main, and then this is going to be the input to the decrypt function. Right, so then n is the numbers dot shape 0, and then we want to make a loop. So we go through each number in the resulting vector when we do the matrix multiplication. So for index in range of n, number is int of numbers 0 comma index, and then decrypted, we just add index to the letter of that number. And let's see, why we do this is because, we take index comma 0, because this will be a column vector, and we want to go through each element in that column, and it will be just one column, so we can just write 0 here. Yeah, and then so this is again what we did here. And then we want to return decrypted. See, is there something wrong here? Alright, so I found the error. We need to close the bracket here. And I didn't see that this became red, but that was the mistake. So now we can try to, well, first we need to find the k inverse, right? And we need to run this function. So k inverse will be of k, and then we want the modulus to be the length of our alphabet. And now we have everything to run our decrypt function. So our decrypted message will be decrypt of this encrypted message and k inverse. And let's see, decrypted message, and we get back help. So that's great. That means that it's working. So yeah, let's see, we can print original message plus message. And then we can print encrypted message, decrypted message, like this. And one more thing is that one thing we can do is that we can have 3x3 matrices, and one I found is a 3x3 matrix. Let's see, let's copy this one. I have two actually. So let's see. Yeah, all right, so it was just an indent problem. But let's say that we have this matrix instead. And I've chosen this matrix because it works for a length of alphabet which is 27. So that means that we can add a space here, and we can have some longer messages that might be more easily read. And we can also, instead of using X here, we can just use a space. So let's say we have another message like my life is potato. Then the spaces will be included, and it will also be included in the decrypted message. So just a little bit extra, if we don't want to use a 2x2 matrix, we can use a 3x3 matrix, And here I have a 3x3 matrix which works for a length of alphabet which is 26 if we don't include a space. And if we include a space, then we can use this matrix. And why we have different matrices is, as I explained in the last video, we need to have that k times the inverse of k in that modulus becomes the identity matrix. But I think that's all for this video. Hopefully it was clear. This is a little bit more complicated than what I'm used to, so it was a little bit challenging for me. Hopefully it was simple to understand. If you have any questions, then please leave them in the comment section. And thank you so much for watching this video.